Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 86 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class we will be using the Kepler kit for Raspberry Pi Pico W. Now hopefully most of you guys already have your gear. If you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick your gear up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I I'm going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 85. But I must first ask, were you successful? If you were successful, leave a comment down below, I am legend. And if you are not successful, leave a comment down below, I folded up like a cheap Walmart lawn chair. But never fear, I'm going to show you my solution, and let's jump on over there. Let me get out of your way and let's talk about what we are going to do today. This was your homework assignment. Your homework assignment was to take this circuit that we developed over the last few lessons. We have 4 LEDs. Last week we had 1 button, and if you press this button, you would increment the LED counter, the binary LED counter. This week you had to add a green button to decrement. So it should count up if I am pointing, it should count up if I am clicking the red button, and it should count down if I click on the blue button or on the green button. So red is up and green is decrement. So hopefully that makes sense. Let's look at how we have this hooked up. Just like last week, we have this LED connected to GPIO pin 16. Okay, this connected to GPIO pin 16, this one to GPIO pin 17, this one to GPIO pin 18, and the leftmost one to GPIO pin 19. And of course, all of that is certainly all certainly hooked to the long leg of the LED, and the short legs of the LED are connected to a 220 ohm resistor through a 220 ohm resistor to the ground rail. We also have the power rail here established by physical pin 36 because we are going to use that for the buttons over here. We're going to use that for the buttons. And so the red button, as it was last week, is connected to GPIO pin 20, and the green button is connected to GPIO 15. We are going to be implementing pull-down resistors, internal pull-down resistors on both of these buttons. And so we have the other leg of the button connected to the power rail, the other leg of the button connected to a power rail, this one again to GPIO pin 20, and this one again to GPIO pin 15. So that's how we have it hooked up. Let's go in and code this thing up. Now what you're going to see is this is going to be very similar to what we did last week. It's just we've got to now have 2 buttons. So we've got to have the button 1 and we got to have the button 2. And you could call it like the up button and the down button, the count up button, the count down button. So you just got to kind of keep track. We have 2 buttons, and all of those variables like the press and the T up and the T down, all that has to be kept track of for the individual buttons. So now let's jump in and let's see if we can modify what we did last week to get this thing to count up or count down. So let me come over here, get a little Windows management done, make sure you can see what I am seeing. That looks good. We're ready to code. So we're using the GPIO pin, so I'm just going to say from machine import pin. Okay, we are going to do a but pin up is going to be pin 20. That is the red pin. That is the red button. When we press the red button, we count up. And then we've got a but pin down, which is the green button, and that is GPIO pin 15. Now we've got to set up those red LED pins. So I'm going to say red pin 1 is equal to 16. The red pin that is worth 2 is connected to GPIO pin 17. The red pin that's worth 4 is connected to GPIO pin 18, and the red pin that is worth 8 is connected to GPIO pin 19. Let's go ahead and set those pins up, and so that we can go ahead and set up the objects for those. And so what I am going to do is I am going to come in and say red LED 1, the object is pin, and which pin? That would be red pin 1, and that is a pin dot out like that. And we're going to leave dangerously, and we're just going to copy and paste this 3 times. Okay, and then red LED 2 is red pin worth 2. Red LED 4 is red pin worth 4, and red LED 8 is red pin 8, like that. So that should have everything set up for us. That looks good. Now we're going to have to go in and we're going to have to set up some variables. Now, I might have misspoke earlier. There's only one press. Okay, we're going to keep track of our total button presses with one variable press. If I press the red button, I'm going to increment press. If I press the green button, I am going to decrement press. Okay, does that make sense? And so press is going to be going up and down based on what those different buttons are, if that makes sense. Okay, I'm just doing a quick look here to make sure that I am saying what I am actually going to be doing. Yes, that does look very good. Yeah, that looks good. Just wanted to make sure that I was using one variable. Indeed, I was. And so this is going to be press, and press is going to be initialized to 0. So when we start, nothing has been pressed, and hopefully that makes sense. Now what I'm going to have is I'm going to start talking about button 1, and button 1 is the red button. So I'm going to say the time for button 1 when it went up is equal to time dot ticks underscore milliseconds, like that. And then the time of button 1, which is the red button again, for when it's pressed down, that is equal to time dot ticks underscore milliseconds. Okay, up and down is whether the button goes up, or whether the button goes down, or the button comes up. So T up is when the button comes up. T down is when the button goes down. Now, what's this one button? This one business, that's button 1. That is the red button. Okay, so hopefully that makes sense. And now I'm going to have a but state, but I'm going to have 2 buttons, and so this is going to be but state 1 old, and that's going to be equal to 0. So this red button, I use the index 1 for it, and if I have that, then I am also going to have a button 2, so I'll just copy this. The button 2 is the green button. That is the button that decrements or counts down, and so that is, we're going to need a T2 up, we're going to need a T2 down, and we're going to need a but state 2 old. Okay, this is the red button that will increment the counter. This is the green button that will decrement the counter. Okay, enough said for all of that. What we need to do now is we need to probably come down here before I define my functions. What I am going to do is I'm going to go ahead and set up the interrupts on those 2 buttons. So first I'm going to have a watch button. Okay, now I'm going to say the watch button that is the decrement Okay, this is watch button down. This is the button, the green button that counts down. Okay, and that is going to be equal to pin, and this is the but pin down counter, and that is going to be a pin.in, and that is going to be a pin.pull underscore down, if that makes sense. Now let's make sure this makes sense up here. Okay, the green button we called butt pin down. We also kind of think of it as the second button. But butt pin down, the green pin, is connected to GPIO pin 15. Now here we're making that green button, okay, which is pin 15 here, we're making it an object that we call watch button down. That is the green button. Maybe it would have made more sense if I called these green or red, okay? But anyway, this is what we've done. Then I'm also going to have a watch button down .irq. I'm going to create my interrupt, and this is going to be a trigger. What do we want to trigger on? We want to trigger on the pin.irq a rising signal, or a pin.irq underscore falling. Okay, so what does that mean? That means that I want to trigger this interrupt whether it is seeing a rising pulse or a falling pulse. When I press the button down, the pulse rises. When I let the button up, the signal falls. Okay, so just understand the nomenclature there. All right, now we need to go ahead and set up our handler. And so I'm going to call the handler. That's what gets called, the function that gets called when these conditions are met, the interrupt switch, int switch, and then I'm going to call it down for the down button. Okay, so that looks pretty good. We're going to take these two, we're going to copy them, make sure you can see those, okay, and then we're going to do the same thing for the up button, the red button. Okay, so here we're going to be doing the red button, which will make the count go up. And then this will be the butt pin up, which is the red one. And then this will become up, up, and then I'm going to have a different handler which deals with if that up button, if the red button is pressed, I need to have a handler for that red button. Okay, that all looks good. So now I think what I'm going to do is I'm going to go ahead and just do the main part of the program, which doesn't do anything, but I'm going to say try, because I want to accept out on a Control-C so I can turn the LEDs off. Then in here I'll have a while true. When is true, true? True is always true. What will I do? Absolutely nothing. I will pass. But then if someone hits Control-C, I will accept on keyboard interrupt, like that. And what will I do? I'll turn the LEDs off. So red LED 1 will be off, like such. Okay, and then now what I'm going to do is I'm going to copy this, Control-C, and then I'm going to paste it, paste it, paste it, and then this will be red LED worth 2, red LED worth 4, and red LED worth 8. So that should turn them all off. Let's just run this and see if we have any errors so we can clean things up before we move forward. Oh, no module name machine. What is that nonsense? Was that from machine? Ah, I see. I was not connected to the board. So let me connect to the board. Now try it. Okay, time isn't defined. Where did I? Ah, okay, I do have to import time. I forgot I was using those timers, so I did need to import time. Now let's run this. Okay, line 2. Oh, import time. Okay, pin is not defined. That's, I see case problem 28. I come over and I have an uppercase I. Hopefully you guys saw that. See, I just like to clean these little things up before I get too far into it. Switch down. Okay, now that's an error. That is an error because, let me get rid of that. This is an error because I haven't gone in and I haven't defined these two functions yet. So that makes sense. So let me go in and define those two functions. All right, so the first one that I'm going to define is I'm going to define the int switch up. So this is what happens, and I've got to pass it a parameter, so I'll just say pin. This is what happens when you press the red button. I'll end up here, all right? And what do I want? I want the global variables of press, because everybody's going to use the same press. Then I'm going to have T for button 1 up. That's the time that the button 1, the red button, was released, okay? Then T1 down, that's the time that button 1, the red button, is pressed down. And then I'm going to have but state old, and this is button what? Button 1. All right, so now I've got my global variables, and I set those things up here. Okay, time 1 and up, time 1 down, but state 1 old, and then the same thing for 2. Okay, that's all looking good. Now I'm going to read the button. So but state 1, the state of button 1, the red button, is going to be equal to watch button up. That was the red button. The watch button up, the up counter button, and that is going to be dot value open close like that. Okay, now but I don't think I need to print that. We're just going to live dangerously. We'll come in and put some print statements if we start getting unusual behavior. Now, when we get to this point, that means you've either pressed the red button down or released the red button. So if but state 1, equal 1, what does that mean? The button is pressed down. The red button is pressed down. Okay? If that has happened, then the T1 down is equal to time.ticks underscore milliseconds. So I'm just recording the time at which the button presses down, and I'm going to compare that to the last time that it was let up. So I let it up, and that is going to be T1 up, and now I am pressing it, and that's going to be T1 down, and I'm going to compare those two numbers. But right now I'm just snagging those numbers. Now also but I better get this right. That's not good. Also, if but state 2 equal 1, or if but state 1 equal 0, that means that something happened, and I'm looking here and the button is up. What does that mean? That means the button was released. How did I end up at this point? The button was released because I triggered, and now I'm reading a 0. So what does that mean? That means that was a T1 up is equal to T1 button 1 when it was released, T1 up. Okay, time.ticks underscore milliseconds like that. So now I have the time that the button was released, and then I have the time that the button was pressed. I have those two very important times because that's kind of how we debounce the switch. So I want to actually increment on the button down. So if I say if but state old equal 0, so what does that mean? Last time the button was up, and this should be but state 1, okay, because it's button 1. If it was 0 last time around, it means last time around the button wasn't pressed. And if but, and that's not old, yeah, and if this time but state 1, my button 1 state, if this time it's 1, what does that mean? I just pressed the button because, Last time around it was up. Something triggered me to get here, and I'm at a 1. That means it went down. And I only want to increment if this wasn't a fast signal indicating a switch bounce. So I want to filter out the switch bounce. So what does that mean? That means that the time.ticks underscore diff between T1 down, that was my down click, minus T1 up, that was the last time when I let it up. If the difference between those two is greater than 25 milliseconds, then I'm going to call it a real, a real button press. Okay, hopefully that makes sense. Now, what am I going to do here in this case? Well, this is what? This is the up counter. This is button 1. This is the up counter. So what am I going to do? Well, in this case, I got a genuine press. So press is equal to press plus 1. Why? This is the up counter. This is the red button. And then what am I going to do? I'm going to print. I'm going to print triggered like that. And then I'm going to say how many times it's been pressed. All right. Now here is where I would do the toggle business on the LED. But before I get into the toggling of the LED, what I want to do first is, just make sure I can go, like if I'm pressing the red button, I want to see 1, 2, 3, 4, 5. And then if I come over the green button, I want to see 4, 3, 2, 3, 4, 5, 6, 5, 4. You see, I want to see that I'm counting up and down correctly. And then we'll take care of incrementing the LEDs properly. Okay, so now what I'm going to have to say, but state 1 old is equal to but state 1 for the next time around. So I'm saving what this value becomes next time's old value, if that makes sense. Okay, so that's pretty good. Do you think I should live dangerously and just copy this whole thing? Let's do that. Let's live dangerously. So what we're going to do here is we're going to come in like this. And now this one, instead of counting up, this is going to be the green button, which is the down counter. And this time this is going to be, we called that the button 2, and we called that the button 2. And this would be but state 2 old. And then this would be but state 2 is watch button what? Down. Okay. This is going to be but state 2. But state 2. This is T2 down. This is T2 up. And then this is but state 2. This is but state 2. And T1, T2 down, and T2 up. And this time, this is the down counter. So if I press that down counter button, what should press do? Press should be press -1. Okay. And then but state 2 old is but state 2. Oh man, I sure hope I didn't miss one of those, because that's going to be hard to find if this doesn't work. Okay. It's going to be hard to find if this doesn't work. Does this at least give me a counter? Let's see if it'll run. Okay. Ooh, right off the bat, line 33, it didn't like. What's wrong with that? Okay, invalid syntax. Line 33, if but state 1 old equals 0 and but state 1 equal 1 and time.ticks is greater than 25 milliseconds. Now let's see what happens. Line 45, yeah, I'll have the same error there because I copied and pasted. So now let's see what happens. Let's run this thing. Okay, pin, again, that is that silly error of the capitalization. You know, uppercase P, you got to be careful and make sure that you get your finger off the button quick enough. Your finger off the shift button. Okay, let's go here. Okay, now that worked. Now let me see if I go this. I got a 1, 2, 3. And you all, this is going to be a little tedious, but I want you to see what's counting there. And so I got to kind of redo my window. And then I'm sure Microsoft is going to try to make this a full size window for me when I don't want that. Okay, that looks good. Now let's see, I go up 4, 5, 6, 7, 8, 9, 10, and then I go down 9, 8, 7, 6, 5, 4, 3, 2. Okay, up, 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 down, down, up, up. Okay, that's part of the hardest problem there. Okay, but now, if you remember last week, do you remember last week how I just came in here and if I got a real trigger, like here, if I got a real trigger, then I just did that toggling of the LEDs, just mod, 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 mod. And I didn't even have to worry about what the actual number was because I was just basing it on where it was last time. But you see, now it gets a lot more complicated because I can't use that same thing because going down, the algorithm is completely different. So I would have to rethink the whole thing and do one on the up, and then I would have to rethink the whole thing and do a different one on the down, and that gets really confusing. So what I'm going to do is I'm going to do one that will work for both of them, and I'm just going to make a function, right, LED, like that, okay? And then over here on the down, I'm going to do the same thing. I'm going to make a function, right, LED, and if you guys struggle, if you guys didn't try to do the homework, then you're going to be thinking, well, what's the problem? If you tried to figure it out, it was kind of tricky to get something that worked for both of them. Okay, so this is what I ended up doing. I created this function, right LED, and this is kind of like, maybe I should have called it toggle, but what I'm going to do here is I'm going to write the press to the LED, okay, and so I'm going to say define right LED, like that. Okay, now what I'm going to do is I'm not going to try to just increment from where I was before. I'm just going to start over and count up to press and put everything in the right state. So I want to start by turning everything off, and that's okay because this would be off for like a microsecond or something, so you're never going to see them go off. And so I'm going to say global press, like that. Now I'm going to say red LED 1, red LED 1 dot off, like that. Okay, now I'm going to copy and paste this, Control C, and then I'm going to Control V, Control V, Control V. Okay, then what am I going to turn off? The 1 LED, the 2 LED, the 4 LED, and the 8 LED. So I start in a very clean, well-defined spot. Now, what do I want to do? Okay, what do I want to do? I'm going to say if okay. I'll do this later. Let me leave that for later because I'll have to explain it. So what I want to do is I want to go for I in range, the range from 1 to press plus 1. I want to go in and I want to set all the LEDs. No, so why do I start at 1? Because everything's starting at 0. So I've got 0, 0, 0, 0. So the first one I want to do, I don't want to start at 0 because I'm already there with 0 working. So I want to start at 1 press, which is when I go to the 1 state, you know, the 0, 0, 0, 1. And so I want to go from 1 to press plus 1. Well, what is my highest number? My highest number is 15. So I want to go all the way up to 15, which would be press. But remember, this range stops 1 before the one you're going to. So if I want to go all the way up to 15 presses, I need to make press plus 1. Right? Hopefully that makes sense. It's just that goofy thing that if you start at 1, you stop 1 before the number that you have there. Okay, so now every time I get here, I'm going to red LED 1 dot toggle like that. Okay, now if the I, my index, and then mod it, right? What did we do last time? We modded it 2, and if the remainder of that one is 0, then what do we want to do? We want to red LED 2, red LED 2 dot toggle like that. Okay, and now if I mod 4 equals 0, if it's divisible by 4 and there's not a remainder, then what do I want to do? That's the case that I read LED 4 dot toggle, and I explained that last week. Okay, now if I mod 8 equals 0, mod 8 equals 0, then what am I going to do? I'm going to red LED 8 dot toggle. Now, what's the difference between this time and last time? Last time I was always going up, so I could just increment from where I was before. But if I might have gone down, I can't just easily do this toggle thing to decrement. So what do? Every time I go back to 0, and then I count to press. And so I sort of rebuild the array every time. And I hope that makes sense. But that is just the way that I found it was very easy to do that. And then I think that is all I got to do there. It's just, I have this little for loop. I jump in here. Now, what is this problem that I said here? All right. What is the problem? What if I'm at 0 and I hit the decrement key? Now I'm at -1. How do I deal with negative numbers? Well, I could crash the program, or I could say, well, if I'm at 0 and I decrement 1, I want to go back down to 16, and then I could count back down from 15. Just like when I get up to 15 and I go up, I go to off, 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 off. So if I'm at off, 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 and I want to decrement, I should go to on, 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 on. And so I can't deal with negative numbers. And so what I will say is if press is less than 0, then what do I want to do? I want to say press is equal to press plus 16. And what this will allow me to do is wrap around, like if I count down to 0 and decrement, it will go to 16. Does that make sense? Hopefully it does. Or maybe I should say it goes to 15, on for 4 becomes 15. Okay, let's see if this works. We're going to run it. No errors. Okay, let's go up. Boom. That's good. That's good. You didn't see that, did you? Okay, we go. Let me go back down. Okay, so we're going to go 1, 2, 3, 4, 5, 6, and then 5, 4, 3, 2, 1. Let's see if I can go to 0, yes, and wrap around to 16. Okay, go. Now let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'll go 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Back around the horn to 0. Okay, guys, I want you to see this is pretty neat. And why did I give you this homework assignment? Because I wanted you to play around with interrupts enough that you start getting comfortable with them. And what is the beautiful thing about this? If you look at our main program, it is doing absolutely nothing. The whole complicated function is being done. The complicated task is being done with nothing but interrupts, leaving your main program for more important things. Like maybe you're playing with a GPS or you're doing other, more important things. You don't have to clog up your main program with a bunch of timing and interrupt handling, or, timing and button press handling and all of that. You just let the interrupt handle all of that. Okay, let's see here. Let me let me think. So that is what, I'm not going to give you a homework this time. Your homework is to get this working. If you didn't get it working, go in and be able to show that you're doing it on your own. And what we've done is the last 5 or 6 lessons have been on timers and interrupts. Okay, this is how we start offloading functions from our main core, from our main Python program, offloading them to timers and offloading them to interrupts. Now, next week's lesson is going to kind of be a logical extension of this. It's going to be a logical extension of it, but it is going to be a very big step forward. And what we're going to do is we're going to go in and we're going to learn about the state machines, okay? Now, the Raspberry Pi Pico W has 8 state machines, and a state machine could be thought of as a very simple little processor. Like, right, we've got big core 1 and we've got big core 2, but there's 8 little bitty processors that can do very simple things. We don't call them microcontrollers, we call them state machines because they have very limited functionality. In fact, there's only 8 commands that the state machine knows. But the things that you can offload, the interaction with the GPIO pins and your interrupts and your shifting data around, you can just offload that to these state machines, and then you can leave your main core 1 and your main core 2 for more important tasks. Now, this is going to be a big step forward for us because you write the program in Python. Okay, but what it actually does, it compiles assembly language and it downloads it into the state machine. So once you run your Python program, your state machines are out there running independently of your Python program, and then your Python program can be doing all the things that you might want it to do. This is called programmable input outputs. It is also known as state machines, and it is also known as sort of doing things in assembly language. And so this is kind of going to be a pretty big step forward, and I'll show you how you can start playing with and benefiting from those 8 state machines on your Raspberry Pi Pico W. Sound good? I hope it does. So guys, I hope you're enjoying taking these lessons as much as I am making them. As always, I want to give a shout out to you guys who are standing with me on Patreon. It's you guys that are keeping me making this great content. So I appreciate the support and I appreciate the encouragement. You can also help me by leaving a thumbs up on the video, leave a comment down below. That helps as well. If you haven't already, subscribe to the channel. And as always, most importantly, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.